So this week's multiple choice Monday is about energy level diagrams, but it's also about rates of reaction because we're talking about a catalyst. And we should know that our definition of a catalyst is that it provides an alternate route or pathway with a lower activation enthalpy. So, for example, by allowing something to bond onto the surface of a metal, this weakens the bonds and this makes the reaction proceed faster because the bonds are broken more easily. So this enthalpy profile is a little bit different to what we're used to seeing because it's endothermic and we don't often see endothermic reactions. They're not as common as exothermic. And what we can see is that we've got an initial line and then we've got a high point and then we go down to the products. So to answer this question, we really should understand what these quantities 1, 2 and 3 represent. Now I'm actually going to start with 3 because that's probably one of the most important when we look at an energy profile or enthalpy profile. So arrow number 3 represents delta H. It's an endothermic reaction. So we're going up, the products are higher in energy, and that there is my positive value for delta H for the reaction. Now, we should have it totally drummed into our heads that delta H is not changed by a catalyst. So the enthalpy change of a reaction, the energy, total amount of energy that is released or absorbed by the reactants as they turn to products, that is not changed by a catalyst, which means actually that's instantly how we get to our answer A, because all of the other options have 3 present and we know that catalyst can't change that. So let's explain why it is A, why it is 1 and 2 and not just, for example, 1 only. So the 1 is my activation energy for this reaction. So the activation energy is the line that goes from the level of the reactants to the highest point. We often talk about activation energy as the minimum energy required for particles to react or to result in a successful collision. And so therefore it is the line, is the difference in energy between where the reactants start and the highest amount of energy they need to be during the reaction, which normally represents some form of bond breaking or overcoming attractions in some way. So what about 2? We don't normally label 2, we normally just label activation energy and delta H. So in theory, if we were looking at the reaction going from left to right, what arrow 2 is the energy released when bonds are made. So arrow number 1 is activation energy, and arrow number 2 is what we would do if we were doing a bond enthalpy calculation. It's the energy given out by new bonds that are made in the reaction. But the other way to look at it is that 2 equals the activation energy for the reverse reaction. Because if you started with the products of this reaction on the right hand side and you did the reaction, which would be exothermic, to the reactants, which are over on the left hand side, so if you did the reverse reaction, then 2, that arrow would be the arrow that went from those reactants to the highest point, which means it's the energy needed for that reaction to occur. So this idea that the arrow up on one side is the activation energy for another and the arrow up on the other side is the activation energy for the reverse explains to us why a catalyst doesn't improve the yield or shift a position if you do have a reversible reaction. Because if I have a lower activation energy, then the catalyst is lowering the activation energy for both the forward and the reverse reactions. So they will both increase in speed and they won't affect one reaction more than the other. The only exception to this is enzymes, and that is because enzymes are so specifically shaped that often they only fit one substrate and therefore they cannot catalyse the reverse reaction. So if you're looking to get a real head start in your chemistry this year and you haven't done so already, sign up to Cation Club. It's a free chemistry revision club. You get emails every few days giving you loads of different ideas to help with your chemistry revision. That's for either year 12 or year 13. You can sign up by going to my website, ckchemistry.co.uk, or you can simply message me on any of the social media platforms or email me. And if you subscribe to my YouTube channel, then I'm going to be doing new videos every week for A-level chemistry this year.